Oh, I got to pause because I didn't take attendance. Ready? Um, Actually, I'm going to pause again. All right, then. So we're kind of taking a little bit of a turn. There's actually only one problem on today's notes that resemble what you did yesterday. Yesterday's, listen, you have to admit that they became pretty boring after about three of them. You don't, I guess you don't have to, but you probably would admit that it just kind of felt like the same song over and over again. Word problems aren't always like that. Like we have to think outside the box a little bit. And so we're going to start here with the variable declaration. Um, I would always recommend with a problem like this, anytime we talk about a pair of numbers, like we're hunting for two numbers here. I already told you what they were, but the point is like, I'm guessing that one of them is going to be bigger than the other. I mean, it has to be if they have a difference. That means one minus the other equals 11. So we're going to declare our variables. And you can, again, as always, go with X and Y. I'm going to say this, and I do this a lot. Let L equal the larger number. And then I'm going to let S equal the smaller number. I find in almost all problems like this, I don't even know if I want to say almost, like I'm not going to write you a word problem where the numbers are both like 13. That's just weird, right? And so there is going to be one that's larger than the other. Depending on like maybe the worksheet that I give you tomorrow, you might see some problems where they're not referred to as the larger number and the smaller number. You might find that they're called like the first number and the second number or something like that. So you just, as always, name your variables in whatever way fits the context of the problem. Okay. Can someone give me an equation for the first sentence? We got to know some math words, but I assume by the time you guys hit ninth grade, you know the word SUM. What is a sum? That's the word I was looking for was added. Thank you. Good. So when you add two numbers, it's called a sum. The sum of 2 and 3 is 5. The sum of 10 and 11 is 21. So how could I write an equation using just the first sentence of this word problem?
L plus is equal to 41.
Facts. 100% irrefutable that if the sum of the two numbers is 41, a fact is that when you add one of them to the other, you will get 41. Okay, good. So anytime throughout this worksheet or tomorrow's or Monday's, whenever we're doing word problems, which will be a little bit, few days, bless you. If you see the word sum, then you're adding things together. Okay. And then we get the second sentence, which says that their difference is 11. What does the difference mean? It means subtraction. And if you're going to subtract two numbers and get a positive answer, then you have to do the larger one minus the smaller one, right? So I know to set my subtraction problem up as L minus S. I don't want to do it the other way around because S minus L couldn't equal a positive number. Small number minus big number is negative, right? And what does L minus S equal? Good. So this was my warm up for you for the day, just to get you familiarized with the fact that not all word problems are about hostas and ivies and cheesecakes and tickets and van rides and stuff. Like this is a little bit outside of what we talked about. But what's nice about this system now that we're done with step two, we're on to step three. What's the sweetest thing about it?
You don't have to.
We don't have to do anything hardly at all. Like this is a level one classic simple fluffer puffer of a system where I'm ready. I can just go right in right now, draw my line, and I can use elimination. We're going to use a lot of substitution today. I would guess probably 70% of the problems, but this one was just why use substitution if something's just screaming, look at me, like add me together. So if I add these equations together, if I add straight down, the S's eliminate. How many L's do I get?
Very 52.
I get 2L equal to 41 plus 11, which is 52. And then I divide both sides by 2, and I now know part of my answer. What's L equal? Perfect, 26. So I threw some flavor in throughout the rest of the notes, but in this one, it's pretty boring. It just says straight up, what are the numbers? Let's just say hypothetically that that last sentence in problem one had said, what is the larger number? You'd be done. you don't always have to, you'll find you don't always have to go and find all the things because no one's asking me for this. But I mean, in this case, I am. But if the problem had said, what's the larger number? You would be done. You'd write a complete sentence and say, the larger number is 26, period. But this problem says, what are both of them? And so we have to do our thing and find the other. Let's just use some simple common sense. If the numbers add together to make 41, I tell you, I got 41 bucks. Some of it's in my front right pocket, some of it's in my front left pocket, but together I got 41 bucks. And if I told you I had 26 bucks in one pocket, could you figure out how much I have in the other pocket? 15. It's like simple math. You just go, what do I have to add to 26 to make 41? The answer is 15. Or you could do it all conventionally and classically and think of it as like actually plugging 26 in. But in a simple case like this, I got no issues with just some good old fashioned mental math. So S is obviously 15 because that's the only way they could add together to make 41. And then we'll answer, we'll say the numbers are 15 and 26. Done. Period. Do you have any questions on that one? Okay. Could someone shut the door, please? Thank you. Let's head on to problem 2. Same variable declaration. Okay, so this will be true for probably 3 or 4 of the problems. I'm not sure, but for this one, again, we'll just repeat ourselves. Let's let L equal larger number, and let's let S equal smaller number. Nice, short, simple variable declarations. No need to be any more specific than that. So here we go. The first equation will come from the first sentence. So what you want to do is, with a good word problem solver knows how to read and interpret, hey, I care about that. You know, like if I had a first sentence that said, hey, I'm thinking of a couple numbers, then you'd be like, yeah, I can go ahead and cross that out, big guy. Like, I don't need that. But we're interested in what it says. Can someone try to construct me an equation that matches from the first sentence? Go ahead, Joshua.
S plus 12 equals 10.
I like it. And you know what? I'm going to just change the order, Josh, just to make it make more sense to everybody in the room. I'm just going to switch your left and right sides, but I want you to kind of watch, if you already knew this, good job, but I want you to kind of watch how I create the equation as I read. So it says the larger number is. So I write the larger number is. And I would say about 95% of the time, the word is going to be your equal sign. So the larger number is. And then it says 12 more than. And what do we think of? What math operation do we think of when someone says more than? Addition. So I'm going to put 12 more than. Notice how I left a space and then put 12. And then 12 more than, oh, the smaller, and the smaller is 12. So good job, Josh. I just, like I said, I flipped it so it would more match the flow of the sentence. Is that okay? All right, let's head on to sentence number 2. We've seen this sentence before. As in like 2 minutes ago. It says the sum of the numbers is 92. What does that mean? What does it mean if the sum of the numbers is 92? If you guys don't know, I understand silent treatmenting me, but if you do know and can actually answer questions, it will make this go better today. Like, I'm not mad if you don't know the answer. I don't like it if you know and then you just want to wait for Josh to answer everything. That's pretty lame. Not 12. It just says that the sum of the numbers is 92. Translate that to English for me. Just that's all I needed to hear. They add up. The pronoun they is, of course, referring to the larger and the smaller number, right? So could you write me an equation that reflects that they add up to 92? There's no 12.
L plus S equals 19.
It's that. The 12 has nothing to do with this equation. This equation simply says the sum of the numbers. That's the sum of the numbers right there. No 12, no nothing. It's just whatever they are added together. That equals 92. Little feedback, even if it's just a thumbs up. Does that make sense? Anything? Okay. Now what we've got is our system. And which method do you think is pretty well suited for this system? And why do you think that is? Let's say I asked you to do elimination. What would be the first thing you would do with elimination? You would get them all lined up. You'd get the L's above the L's, the S's above the S's, the equals above the equals, and the numbers above the numbers. I look at this system, and on that note, I say, this one's really not very ready for elimination. Just because of the top equation, I've got a rogue S. Could I fix it? Sure. If I asked you to do substitution, what would be the first thing you would do? I'm going to ask this again. If I asked you to do substitution, what would be the first thing you would do? Substitution. What's our first step when we do substitution? I'm not ignoring you, by the way. I just need a little bit more. So I think that this probably is something I need to say again, since I do think, based on your silence, that you don't know what it is I'm asking of you. When we do substitution, we need to get one of the variables by itself. It's been a hot minute. You took a quiz on this quite a while ago, like 5, 6 days ago or something. And so maybe you forgot that the first step with substitution is to look at the four letters and ask yourself which one would be the easiest to get by itself. I'll tell you what, guys and gals, it doesn't get any easier than the top equation. It's already solved for L. You would agree. Usually I look for a variable that doesn't have a number with it or a negative with it, and then I move something to the other side and then I box it up. I look at this problem and I'm like, yes, please, and thank you. It's already ready for substitution. The first step when I say I want you to do substitution is to get a variable by itself. If one of them is already by itself, take it and run. You will see that somewhat frequently throughout these problems. Okay. Now, what are we going to do with the red box? What do we do? What's the second step in substitution after we get a box? What do we do with it? We move it and we put it in place of something. What do we put it in place of?
L.
The L, because L's what we got by itself. Whatever I got by itself, I replace that one. We're not used to L's and S's and all, but we're not scared. It's okay. I'm going to say, okay, if U equal S plus 12, then I should be able to take S plus 12 and put it wherever I see an L. And hey, I happen to see an L right there. So I'm going to take that L that I just underlined and I'm going to pull it out. It's going to take the day off and a substitute is going to come in. And in the place where L used to be, it's now going to say blank plus S equals 92. And what's going to go in that blank? Everything in the box, S plus 12. That thing in parentheses used to say L, but now it's L's other name. And now we solve. 100% unnecessary use of parentheses, right? I don't know if that would be like a 15-yard penalty in football or something, but not bad to use parentheses when you don't need them. I just thought I'd put them there so that we'd have a blank to fill in. Okay, now let's solve this equation. What do you see over here on the left-hand side? Me too. Well, let's put them together as an idea. What is S plus S? I like it. So now we have 2S plus 12 equals 92. Next step, subtract 12, and I'm going to kind of move up here. We get 2S equals 92 minus 12, which is 80. Last step, and 80 divided by 2 is 40. So what did the question ask us to find? So again, dang it, if it had said what's the smaller number, then we could be done. We could say the smaller number is 40, period. I'm out. But it does kind of annoyingly say what's the larger number. So I don't know that yet, but I can find it pretty easy, right? I know they add up to 92. So again, I can use some simple little kitty logic to figure out the other one, or I can do the old classic and I can take the 40 that I know and I can put it into the old trusty box. It doesn't matter. What is the larger number? It's got to be 52. Goes back to that idea. If I've got a total of 92 and I got 40 in one pocket, the other pocket's got to have the other 52, right? Just basic arithmetic. So now we have found what we set out to find. We had to find the smaller number to get there, but that's okay. We got there. Now we can write our sentence and we can say the larger number is 52. Do you have any questions so far? All right, let's get on to problem 3. Take a moment, read it. What are we looking for?
No.
Nice. And so, there's a decent chance that we're probably going to we're going to need both variables anyways, but you're right. We just want to know at the end of the day, if we happen to find boys first, awesome, dude. But we do need 2 variables. So what do you think we ought to use? I would use G and B. So I'm going to let G equal number of girls. And I'm going to obviously let B equal the number of boys. It's just situational awareness, okay? Don't panic. The second sentence, by the way, is the easy one. Let's get the hard one out of the way first. The first sentence is really hard for a lot of people to interpret. I'll give you a moment. Try to construct a sentence using letters, equal signs, and numbers. I'm ready, Jeff. You think you got me an equation?
Yeah.
I'm ready.
B equals negative 14 plus B.
I love that equation. I'm going to modify it just like I told Josh. I love what you said. I'm just going to make it look a little different, but good job, Jeff. The number of girls is, listen, again, good job. These 2 symbols that I just wrote, they literally replace everything that I just underlined. I just murdered off 1, 2, 3, 4, 5, 6, 7, 8, 9 words with 2 quick, cute little symbols. The number of girls is bam. And the only thing I'm going to say about what Jeff said is, again, he is very correct. I'm just going to try to coach into you that whenever you see these 2 words, less than, I want you to do backwards subtraction. Less than in the human mind should think about something minus what I say. Let me ask you a math question. What's 5 less than 8? 3. And the reason you know that is because you did 5 less than 8. Do you see how I did that? What's 4 less than 9? Because you did 4 less than 9. If you watch yourself write that a couple times, you'll realize that the construction of this is actually pretty logical. 14 less than the number of boys. Gorgeous. I can tell you, having taught some semblance of this unit now for almost 30 years, that the words less than are the cause of a lot of red ink on quizzes and tests, okay? So respect those 2 words and remember that it's not 14 minus B. That wouldn't work. It's got to be B minus 14. All right, the other equation by now, you should know. There are 354 total kids. What's our equation for that? Perfect. Number of girls plus number of boys, straight up 354. Comfortable so far? I'll ask you the same questions I asked you before, and your stunned silence I didn't take personally, but I hope I can get a little bit more out of you this time. Let's think about, now that we're done with step 2, which of the methods, I'm not even ever talking about graphing, so which of the 2 methods does this lend itself to? 1,000,000% for the win, substitution. And I understand, again, I think about substitution and I say, gosh, if only there were a variable that were easy to get by itself. And then I say, wait, I can up you. I can take you up a level. Holy smokes, there's already one that is by itself. My God. So whenever that happens, take it. Box it up. Where are we going to throw in that red box? In place of the G, since it's the G that we got by, well, we didn't even do it, but I mean, it's by itself. So I'm going to, again, have unnecessary use of parentheses, but the bottom equation is now going to say blank where G used to be plus B equals 354. What's going in the blank?
B silent.
And we find ourselves yet again with a very, very simple algebra problem to solve. Unnecessary parentheses, they mean nothing to me. How many B's do we get on the left?
2.
And if we add that 14 across to the other side, what's 354? Thank you, 368. And then if we divide both sides by 2, what do we get? Perfect. What did we just learn? In the context of this problem, what did we just figure out? The answer, how many boys there are. These are both beautiful things for you to say. I just learned that there are 184 boys at Pollock High School. That's what the problem asked me to find. So here's an example of one where you don't even have to go back and find G. Like, no offense, girls, but in this problem, just not interested. They asked me for the number of boys. I got the number of boys. I'm done. I'm checking out. So I'm going to write a sentence and say, there are 184 boys at Pollock High School. Done. So I want you to be smart. And when you read a word problem, sometimes be aware of the fact that the first thing you find may, in fact, be the only thing you have to find. Are you ready for problem 4? Okay, good. This is a lot. And this is where I think this is the one that I think will be one of the harder ones for you today. But again, if you can construct like Jeff did last time, if you can just have faith in yourself and read the sentence and construct, they're not as bad as they seem, but they are difficult. Way more difficult than that stuff we were doing yesterday. So first off, let's declare our variable. So again, it's the old normal. Let's let L equal larger number. And of course, we'll let S equal the smaller number. As obvious and stupid as that seems, we do it. We declare. Okay. Some sort of sadistic weirdo out there that declares L as the smaller one. Well, at least we'd know, but we're doing it anyways. All right. I would like to do this in pieces with you. I'm going to underline 6 words. And I want to know, and Jeff's already proven that he can do this, so I'm going to kind of take Jeff out of the loop here, no offense, but someone else, I would like someone else to give me some math symbols that replace the words I just underlined. Thank you. Good job. The larger number is. Sometimes people think it's, but it says the larger of 2 numbers. I mean, give me a break. That just says the larger number. That's just in English how we say things, right? He's the older of my 2 children. Oh, you mean so he's the older child? Like, I mean, don't make a mountain out of a molehill here. Good job on that one. L equals. Awesome. Okay, I'm going to circle 3 more words. I count a number as a word just because I don't want to say it any other way. Can someone replace that for me with 2 symbols?
3, 1.
Yep. And because it says the word then, I am going to put it in the back. I believe that anything that says then, greater than, more than, less than, fewer than, should always, English-wise, flow-wise, go in the back. So 3 more than, I think, should be space plus 3. That should feel correct to you. If you always do your THANs, your thens in the back, you'll never get the less thans wrong because you just always do it this way. And then finally, see, word problems don't have to be hard if you chunk it. This is chunk. We call this chunk reading. I'm just taking chunks. What is 2 times the smaller?
Okay.
So I can just stick that right in there. And that sentence that once looks like a big scary monster, we realize now is like, that's easy because we chunked it. It doesn't get easier. What I did to you from early in the assignment, the notes, was I gave you 1 hard equation and 1 easy equation. Now I've given you a hard equation and another hard equation. So again, our only hope here is to chunk. So here it goes. I'm going to switch colors. If the larger number is increased by 3 times the smaller number, holy smokes. I can replace all 12, 13 of those words, whatever it is, with a few short symbols. Anyone want to take a shot? Jeff?
Oh, L plus 3S equals 73.
I like the first part. I'm just not going to. I like the first part. Jeff is crushing this. And I hope more of you are too. L plus, so if the larger number is increased by, that's what I have, 3 times the smaller number. I don't even have an equal sign, and Jeff nailed it, but I wasn't ready for the equals yet. I just want to know that you know that that's what it means to take the larger and increase it by 3 times the smaller. Good job, Jeff. If the larger number is increased by 3 times the smaller, what is the result is 73 mean? Of course, equals 73. And I have to ask you this question again. This is my job and I care about you. Which method is just calling to you? Substitution. If you wanted to do elimination, I'm not going to stop you, but I'm not going to like look this gift horse in the mouth. Like, thank you is what I'll say. There's a box. What are we going to do with the box? I'm going to stick it in place of L. And our new bottom equation is going to say blank where L used to be plus 3S is 73. What's going in the blank? Perfect. And now we just algebra. I mean, this is why we learned to solve equations in August, so we don't have to talk about it all year. Put your S's together. What do you get? 5S. Subtract your 3. What do you get? 70. Divide by 5. What do you get? 14.
Yeah.
70 divided by 5 is 14. And now I read the question and I'm looking and like crossing my fingers going, come on, man, I hope they ask me for the smaller. And I go, no, they asked me for both. Okay, so I guess I got to finish the job. So I'm going to take the number 14 and I'm going to go what I'd always do and I'm going to put it back in the box because I got to know the other one too. What's 2 times 14? What's 28 plus 3? So I guess the larger number must be 31. And now I write a sentence and I say the numbers are 14 and 31, period. Here's what we're going to do. We're not going to finish the notes, but we're going to try. We have 9 minutes of class left, so I'm just giving you a heads up that this lecture, unfortunately, will probably not conclude today, but we're going to go to page 2. You're going to turn your notes over, and we're going to try problem 5. And if we get done with 5, then we're going to start number 6. So let's get in there and give it a go. Are you feeling it? Like, are you understanding? Like, I can do this, right? You talk to people about math and like, oh, I hate word problems. And it's just like this stereotypical sort of almost ignorant thing to say. You should not hate word problems. If you think about it, think about what is the likelihood that you're ever going to use all this stuff I'm teaching you in your daily life? Almost zero, right? Like when, as an adult, are you going to use algebra and graphing lines? But so when people say word problems are what I don't like, I get in their way and I say, wait a second, if God forbid you ever actually have to use math in the world, guess what? Newsflash. It's going to be a word problem, right? If any math you use in your life is going to start as words. So think about that. And I don't want you to walk out at the end of the year and be one of those people that still goes, oh, word problems. Like we should embrace word problems and understand that this is what it's all about. All that other stuff is just the underlying basic skills that we need to solve word problems. So in this problem, what are our variables going to be? That's perfectly sensible. So let's do soda first. So let S equal number of calories in a soda. And then let's let P equal the number of calories in a popsicle. All right, with that annoying nonsense out of the way, we're now on to step 2. And again, it's not about reading a whole sentence and going, oh, I got to go ask for help. It's about chunking. So let me underline some words. And if I call on you, I want only a replacement for those words that I have underlined. The number of calories in a soda is done. S equals. Beautiful. Now I'm going to circle 3 more words. And I would like you to replace just those 3 words with math. What would it be? It's something, but the ones I have circled, since it says 20 less than, are leave a space minus 20. I'll say it again and again and again and again. When you see that word THAN, greater than, less than, more than, fewer than, put it in the back. And what is it 20 less than? Twice the calories in a popsicle? 2p. Gorgeous. That's a scary sentence until you learn how to do it. And then you realize, chunk it, baby. Read a few words, put a little math down. This one's easy. I gave you a freebie. Together, a soda and a popsicle have 430. That's easy. This is our fourth time today. What's this equation? Yeah. S plus P. Good job, Jackson. S plus P equals 430. That's that old they add together thing. We love those. Sorry. Fourth verse, same as the first. What method is just yelling at us? Again, if it's going to come to us, we're going to take it. S equals, it's like, look at me. Box me up, baby. Ready to go. Where are we going to put that box? Yeah. So our bottom equation is now going to say awkward space where S used to be plus P equals 430. And in that awkward space where S used to be, I will put the contents of the box, 2P minus 20. And yet again, we find ourselves using skills that should not be difficult. It's why we learn the skills before we do the word problems. If you put your P's together, a 2P plus a 1P makes 3P's. If you add the 20 to the other side, 430 plus 20 is 450. Divide 450 by 3 and you figure out that P is, what's that? Man, that is one of the smartest things anyone has ever noticed. I had no idea how lucky I am that you're willing to think that way. Here I am, just your brainless math teacher. And look at, did you hear what Nash just said? Did you guys catch that? I don't know in 29 years if anyone has ever stopped me at that point in a lecture and pointed that out. I've probably never done this exact problem, but dude, that was awesome. That deserves a piece of candy. Hold on a second. Do you want some candy? How about some Lifesaver gummies? Ready? Oh, sorry, Peebo. That was such a beautiful observation. That is so awesome that you're willing to think so confidently about mathematics. Here I am just going about my business, and Nash is like, whoa, slow your roll, brother. What does the problem ask us for? And I'm pretty sure it says it whoop, right there. Dude, you just blew my mind. Top notch. So listen, that's awesome. So P is 150, and then you might go back, and then but again, do what Nash did and just think outside the box like that, dude. I'm so proud of you for making that call. So I would write a sentence, and I would say there are 450 calories in 3 popsicles. That was amazing. Okay. Let's start number 6 and see how our progress goes. And I'm not going to write a sentence just because I want to try to get to another problem. You can do it later because it's your own notes page. So there are 450 calories in 3 popsicles. You get the idea. All right, let's go to number 6. Oh, we got another hard one. So let's declare our variables. Let L equal larger number, and let S equal smaller number. All right. I'm going to underline some words. By the way, I don't do this just for my health. I do this because I'm trying to do what we call in teaching, it's called modeling. I'm trying to model a behavior that I want you to do. So when I underline chunks like this is how I want you to think, because when I'm not there to help you, this will help you without me. I'm just going to underline a portion. The sum of 2 numbers is. Replace that. Missing one thing. The sum of 2 numbers is, so I'm going to put in equals. Nice job. Now, again, please don't read me the entire right-hand side. I'm just trying to do this in chunks. Just the 3 words that I have circled, replace those. Blank minus 6. Because it says then, less than, more than, fewer than, greater than. Put them at the back. Twice the larger, what's that? Good job. I'm going to see if we can construct this equation, and then I'll let you pack up. But don't even look at the clock, okay? I won't make you late. One more equation. If the larger number is decreased by 3 times the smaller. What does that mean? Decreased by, holy smoked ham! If the larger number is decreased by 3 times the smaller, God, that was beautiful. The result is negative 12. Gorgeous. So we are going to stop right here because this is not perfectly set up for substitution and it's not perfectly set up for elimination. We'll continue this tomorrow. Got maybe 7, 8, 10 more minutes to go. Tons of work time after we finish the notes tomorrow.